Hello friends, welcome to VK Lectures. In this lecture, we will be discussing the question number 59. For spin half particle, let up and down denotes spin up and spin down states respectively. And if A equal to 1 by root 2 up down plus down up and B equal to 1 by root 2 up down minus down up are the two composite states for the two particles. Which of the following statement is true for their total spin S? Now let us discuss what is A and B. Now we have the two spin states. So let's start with what is given. We have two spin states. One is up and another one is down. Okay. Now these two states combine to form the composites. So we have another state A such that it is a combination of these two. So how we can write A? A is 1 by root 2 and this root 2 is nothing but the normalization constant. For the two states, it will be equal to up, down, plus down, up. So if you have two states up and down for the two particles, then their combination will be either this way. Now this corresponds to the symmetric state. Symmetric state, which means it is a triplet. Now why triplet? This is symmetric state, triplet, and S is equal to 1. Now the net spin varies from minus 1 to 1, that is minus S to plus S. The net spin. So minus 1, 0 and 1. These are the three states available for this particle or this state to occur. So this becomes the triplet state. Triplet state is nothing but the symmetric state, and for triplet state we have the S is equal to 1. So S is equal to 1 for the triplet state. So for A corresponds to S is equal to 1. Now come back to the state B. B is written as 1 by root 2 and its combination of both up, down, minus down, up. Now this is an antisymmetric. Now why antisymmetric state? If you replace these states, you will not get the same state again because you have a minus sign. But in the case of A, if you replace any of these states, you will get the same state because you have plus sign in between. Both are plus, plus. Here this is plus and this is minus. So this becomes an antisymmetric state. So antisymmetric state means it is singlet. For singlet, S is equal to 0. Net spin will be also equal to 0. So for the state A, it is S is equal to 1, and for state B, S is equal to 0. So A corresponds to S is equal to 1 and B corresponds to S is equal to 0. So coming to the options, S is equal to 1 is not an eigenstate. S is equal to 1, it is not an eigenstate, it's a spin. A is not an eigenstate of the operator S square. S1 equal to 0 for B. No, this is also not true. S is 0 for A. No, S is 0 for B. And S is equal to 1 for B. And no, this is reverse. So S is equal to 1 for A. Yes, this is true. And S is equal to 0 for B. This is true. So the fourth option is the correct one. But according to the KEA answer sheet, answer key, the option marked is option 3. But this is not true. It's again a mistake from their part. The correct option is option 4.